Hello everyone, this is me Samiha Hassan from the page whiteboard, and today I will explain how to draw the shear force diagram and the bending moment diagram of a simply supported beam under point load. Okay, so before that, at first we need to know what is shear force and what is bending moment. So here I have taken a simply supported beam AB and I have various vertical forces that are acting on this beam, and these forces are known as the shear force, and the moment that will be created due to this force is known as the bending moment. And we're going to consider the shear force positive if it produces clockwise moment, and we are going to consider the shear force negative if it produces anti-clockwise moment. So without any further delay, let me go and take an example and draw the SFD and BMD of that example. So for drawing the SFD and BMD, at first we will have to know the support reaction of A and B. So as this is a pin support, it is going to have two reaction, which is AY and AX, and as this is a roller support, it is only going to have one reaction, which is BY. And now at first I will have to find the reaction forces. So for finding the reaction forces, at first I will take summation of f of x is equal to 0. From here I can understand x is equal to 0 as there are no other horizontal forces acting on this beam. And after that I'm going to take summation of fy is equal to 0, and it will give us ay plus by minus 50 is equal to 0, and I will have ay plus by is equal to 50. Okay, so I will name this equation as equation 1, and then I'm going to apply my third equation of equilibrium, and I will take moment at A is equal to 0, and I'm going to take the clockwise directions as positive, and then I will have 50 into 10 minus 20 into by is equal to 0. So I will have 20 by is equal to 500. After that I will have by is equal to 25 kilonewton. Okay, and now as I know the value of by, let me put it in equation 1, and I will have ay is equal to 50 minus 25 is equal to 25 kilonewton. So here is my diagram, and now I will draw my SFD and BMD. So at first I will have to draw my SFD following this diagram, and then I will draw my BMD following my SFD. So let me draw my line for my SFD. So above this line the value of SFD will be positive, and below this line the value of SFD will be negative. Now if I look at this diagram, then I can see that I have a 25 kilonewton force at point A going upwards. So I will have a positive 25 kilonewton over here, and there are no other forces, so I will have a straight line. And then I have a 50 kilonewton force going downwards. So I had a positive 25 kilonewton force, and then I have a negative 50 kilonewton force, and I'm left with negative 25. So my value will be negative 25. And now I don't have any other force, so this will continue up to here, and here I have a positive 25 kilonewton force. So negative 25 positive 25 left us with 0. So I will have a 0 over here. This will be positive and this will be negative. Now the value of my bending moment will be the area of my shear force diagram. Let me write it over here. value of bending moment is equal to area of SFD. Okay, let me draw my line over here, and at the supports there are no moments, so the value of the moment will be 0 at the support. Now I know that the value of my bending moment is equal to the area of the SFD. So the area of this portion will be 25 into 10. So 25 into 10, and this is positive, so positive 250, right? Positive 250, and as this is a positive area, slope of my bending moment will be positive. It will be 250. And after that, if I work with this part, then I can see that the value will be negative 25 into 10, which is minus 250. That means at this point the value of my bending moment will be 0. And as this is a negative area, so my slope will be negative. So it will come all the way down, and this is my BMD. So here I have taken another example, and there are 2 point loads in this example. One is situated at a distance of 5 meter and another is situated at a distance of 10 meter. So like the previous math, at first I will have to find my reaction forces. So again I'm just going to do the summation of f of x is equal to 0. So x is equal to 0, summation of f of y is equal to 0. So ay plus by is equal to 50, 60, 70, 80 kilonewton, and summation of moment at a is equal to 0, and clockwise direction positive. So 30 into 5 plus 50 into 10 minus 20 by is equal to 0. So 150 plus 500 is equal to 20 by. So by is 32.5 kilonewton. Now ay is equal to 80 minus 32.5 kilonewton. So I'll be left with 47.5 kilonewton. Okay, at first I need to draw my SFD, and as 47.5 kilonewton is going upwards, then I will have a positive force of 47.5 over here, and as there are no other forces, it will go up to here as a straight line, and then I have a 30 kilonewton force going downwards. So I will have to deduct 47.5 minus 30, and I am left with 17.5. okay, so I will be over here. So suppose this is 17.5. okay, and there are no other forces, so it will be again a straight line, and then I have another force of 50 kilonewton going downwards. So I will have 17.5 minus 50. okay, so 17.5 minus 50 is 32.5, negative 32.5. so here it is, suppose minus 32.5. so I will go up all the way up to here. Here's my negative 32.5, and it will go again, it will go as a straight line as there are no other forces. And then I have my positive 32.5, which negative 32.5, positive 32.5, and I am left with 0. So positive area, negative area. This is my SFD. So as I've said earlier that the value of my bending moment will be the area of my shear force diagram. So let me see what happens over here. This is my BMD. Okay, so at first I have 47.5 into 5, which is 237.5. So let me assume that this is somewhere 237.5, and as this is positive, so I will have a positive constant slope. Okay, and this one is 237.5. okay, and now I have another area which is also positive, so I will have to add this value with the previous value, and let me find the value. So 237.5, I have it with me, plus 17.5 into 5, so it's 325. So the value of bending moment at this point will be 325, and as this is also a positive value, the slope will also be positive over here, and this is my 325. okay, and now I have a negative area, and let me see what is the value of this area. So negative 32.5, I will add minus 32.5 into 10, which is 325, left us with 0. So I will have a bending moment of 0, and as this is a negative area, so I will have a negative slope over here. So this will be my bending moment.